Our essential questions today are: how is density calculated and how is it used? To start out, we're going to start with the formula for density. Density, wow, that's bad. Let's try that again. Density equals mass divided by volume. Now, there's an easier way to remember this that will help you anytime you need to manipulate this formula and solve for something other than density. To start, we're going to draw a circle and divide that circle in half horizontally. Ooh, I almost got a straight line. And then we're going to divide the bottom in half vertically. To fill the circle, we start with the bottom right-hand corner. Nope, that's left. The bottom left-hand corner with density. On top goes mass. On bottom goes volume. So we have the DMV, like Department of Motor Vehicles. That's how I remember it. It goes in order DMV. And the way to use this is I can cover any variable I'm trying to solve, and that gives me the formula that I'm looking to solve for. For example, say that I want to solve for mass. Well, no, let's solve for density. If I solve for density, I'm just going to cover up density, and my formula is mass divided by volume. If I'm trying to solve for volume, I can cover up volume and find out that my formula is mass divided by density. If I want to solve for mass, I can cover up mass and find out that my formula is density times volume. So that right there is a great way to remember the formula for density because it helps to manipulate the formula and you don't have to do as much algebra. Let's do a practice problem with this. I have a metal with volume of 25 milliliters, and a mass of, I don't know, 100 grams. It's a pretty dense piece of material. It's pretty heavy for its size. And I want to know, what's the density? What's the density of this particular object? So to do that, I'm trying to solve for D, so I'm going to cover up D. And that tells me I need to put M over V. Well, my mass, let's see if I can color coordinate this. My mass is 100 grams. The unit for mass is always grams. So I'm going to put grams on top. 100 grams go on top. On bottom, let's see if I can find good colors for this. On bottom, I'm solving for volume. My volume is 25 milliliters, so I'm going to put milliliters on bottom. And then I need to divide this. And this is something that you should be able to do in your head. 25 goes into 100 4 times. So my mass is 4 grams per milliliter. That's my unit for density. My unit for density is grams per milliliter. That's something worth writing down. So the units, the typical units, usually the units are grams per milliliter, but you could also do grams per liter. Every once in a while we see it in grams per liter. But grams per milliliter is the one that we see most often. That's the one we see most often. Let's take another practice problem and see if we can solve for something other than density. So again, we've got our circle. I have density, mass, and volume, or Department of Motor Vehicles, whatever works best for you. All right, so I need a practice problem. What is the volume that's supposed to say volume? Volume of, wow, that's really bad, of an object that is 32 grams and has a density of 0.8 grams per milliliter. So what are we trying to find here? This time we are trying to find the volume. We're trying to find the volume. So I'm going to cross out volume and find that I need to put mass over density. I need to put mass over density. So mass, remember mass is measured in grams. Well, I have grams here, but that's not what I'm looking for. That's grams per milliliter, that's my density. So my mass must be this number here, 32 grams. So I'm going to put 32 grams on top. Remember, always, always to include your units, no points, and that applies to any math that you do in chemistry. My density needs to go on the bottom. Density is going to go on the bottom, and that's this number here, the 0.8 grams per milliliter is going to go on the bottom. And I need to solve that. Well, that one's not as easy to do in my head. So I'm going to get my calculator. Bring my calculator in here. So I have 32 divided by 0.8. 32 divided by 0.8 comes out to 40. I should have been able to do that in my head, but you know, I never was good with my math times tables. So 40 is the number. Now what about the units? Well, there's a couple ways we can go about this. We can say I'm looking for volume, and so volume will return me units in volume. My units for volume are milliliters. So 40 milliliters is my answer. There's another way we could look at this as well, and that deals with fractions. We're getting ready to start part of the unit that deals exclusively with fractions, so it might be helpful for us to take a look at this. Anytime I have something divided by itself, that equals 1. So I have grams on top, I have grams on bottom. Those can cancel out because anything times 1 is irrelevant in a math problem because it returns the same value. So I can cancel those out. That leaves milliliters left. That means it's my units here. All right, so what do we use density for? That's our next question. What do we use it for? We use density to identify materials. We use density to identify materials and their behaviors. We use density to identify materials and their behaviors. For example, all the samples, all the samples of gold in the world, gold is AU, all the samples of gold in the world have the same density. All of them. So if you're curious to know if your gold chain is pure gold or if it's a gold coated chain, or if it's got part silver and part gold, you can actually measure the density of it to find out if it's pure gold or not. And this property, this physical property of density, is true for all elements, all samples of an element, of a given element, have the same density. So it doesn't matter if I've got a tiny piece of carbon or a huge piece of carbon, that carbon is going to have the same density regardless. It doesn't matter if I've got a little piece of aluminum or a huge block of aluminum, the density will be the same regardless. And this helps us to identify the matter. The last thing we want to talk about is ranking density. Ranking densities. Oops, there's my cursor. So we can rank densities. And when we, I'm sure that you've done this before. Have you ever put oil and water together in the same container? And then what happens? The water hangs out at the bottom, and the oil hangs out at the top. That's always what happens. Every single time, that's what happens. And a lot of people think that's because the density, a lot of people think that the oil weighs less. Well, that's not quite true. What's happening is the density of water is greater than the density of oil. So if I pour a bunch of things in a tube or in a graduated cylinder, they will arrange themselves by densities. The highest density goes to the bottom, and the lowest density goes to the top. The density of water, by the way, the density of water is 1.0 grams per milliliter. So what does that say about the density of oil? Well, of course, it has to be less than 1. The density of oil is less than 1. It has to be, because oil floats on water. If I were to put a rock in here, the rock, chances are, the rock would sink to the very bottom. So here's my rock. What do we know about the density of the rock? Well, we know that the density of the rock is greater than 1.0 grams per milliliter because it sank to the bottom. This is true no matter what happens. We can always rank densities based on what they do with each other. The highest density sinks and the lowest density floats. That is worth writing down. High density sinks, low density floats. Okay, and that's true regardless of what materials you're working with. All right, that's about it.